Okay, hello everybody, and welcome to Chapter 8, where we're going to start with actually something that's not in your textbook. But before we do, I'd like to introduce you to somebody. Here's my daughter. Say hi, Kylie.
Hi.
Isn't she cute? All right. Well, this lesson is important for us to be able to handle the next part of our geometry stuff. So we're going to call this 8.0. It's not in your textbook. Simplifying radicals. A radical expression is an expression that contains a radical. That's not surprising. The symbol for a radical looks like this. You would say that's the nth root of a. What that means is what number multiplied n times is equal to a. A numerical version of this would say the fifth root of 32 is 2. The reason it's that is because 2 to the fifth power is 32. So what number multiplied by itself 5 times is 32? 2. So that's what radical stuff means. The most common radical is a square root. That's the one you've certainly heard of before. The square root of 25 is equal, well, there's an implied 2 right there when we're dealing with these square roots. You don't normally write the 2, but that means the square root of 25. What's multiplied by itself 2 times? Of course, 25 is 5 squared, so what's being multiplied by itself 2 times? 5. The square root of 25 is 5. There are a bunch of perfect squares that we'll need to be familiar with, but so that we can take square roots. Because this lesson is really about simplifying radicals. There are a couple of rules, 3 rules really, that we got to follow for simplifying radicals. The first one for putting radicals in simplest form: you cannot have a perfect square factor other than 1 inside a radical. Now, what are the perfect squares? 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, etc. 20 squared is 400, is a pretty common one as well. So you can have no perfect square inside a radical, or from the prime factorization form, you can't have any factors appear twice. I'm going to show you what I'm talking about with these examples. Square root of 50, I'm going to do it a couple different ways. The first way is to use the perfect square factor in here. We're going to ask ourselves, what perfect square goes into 50? 4, 9, 16, 25. Oh, 25 does. So we can break down 50 into 25 times 2. Well, we can take the square root of 25, but we can't take the square root of 2, so we do take the square root of 25. It's a 5. It comes out of the radical. But the 2 stays in, so we're left with the value 5 square root of 2. And that's what the square root of 50 is, simplified. Another way to do this is to break 50 into its prime factorizations. 50 is equal to 2 times 5 times 5. So what number is being multiplied by itself 2 times? Inside of 50, the 5. So we can take the square root of 5, it comes out, the 2 stays in, and we're left with 5 square root of 2. As you do these right here, I want you to try both ways to see which one feels better to you. I'm actually going to do example 2 over here, and square root of 72 3 times. First, I'm going to do it this way. What goes into 72? Does 4 go into 72? It does not. Does 9 go into 72? Yes, it does. 9 goes into 72 8 times. So we can take the square root of 9, it's 3, but then we're left with the 8 inside. Well, what goes into 8? Does 4 goes into 8? I lied when I said 4 doesn't go into 72. It does. But 4 goes into 8 as well, so it's 3 times the square root of 4 times 2. Well, we can take the square root of 4, but not the square root of 2, so we're left with the 2 comes out, the other, or 2 stays in, so we're left with 3 times 2, square root of 2, which simplifies. 3 times 2 is 6, square root of 2. A simpler way of getting there is to say, what is the biggest square root that goes into 62? And you could start with, of course, 64 is way too big, 49 is too big, 36 goes into 72 2 times. So we can take the square root of 6, but we can't take the square root of 2. So it's a lot simpler to go with those bigger numbers. The prime factorization method over here in purple, 72 breaks down into 2 times 2 times 2 times 3 times 3. What factor is being multiplied in there twice? Well, there's 2 2's. There's actually 3 2's, but we can pull 2 of those out, and we can pull the 2. We can pull 2 of the 2's, 2 of the 3's to get a 2 and a 3 coming out. And then this lonely little 2 stays in, so we're left with 2 times 3 square root of 2. Simplified, of course, is 6 square root of 2. So what is the square root of 72? 6 square root of 2. There's 3 different ways of getting there. You got to get good at least one of them. So I'd like for you to try these 4 here and see what you can come up with. Hopefully you'll get the right answers. All right, here's what they simplify to. Hope you did well. Okay, the 2 other rules really go together. You cannot have a fraction that is in a radical, and you can have no fraction that has a radical in its denominator. If you have either of these, you will have a process called rationalizing the denominator. Here's how this works. Example 3 here, we have square root of 2 or the square root of 6. We have a radical in the denominator, or we have a fraction with a radical in the denominator. To rationalize by the denominator, you're going to take the denominator and turn it into 1. So where we have a square root of 6 on the denominator, we're going to make it square root of 6 over the square root of 6, which would cancel out into 1 if you did. So it allows us to multiply the square root of 2 over the square root of 6 by it and not change its value. Now when you multiply radicals, you can multiply the numbers that are inside. So a square root of 2 times the square root of 6 is the square root of 12. The square root of 6 times the square root of 6 is the square root of 36. We can simplify the square root of 12. That's 2 square root of 3. You can pull the 4 out, or 12 is 2 times 2 times 3. And then the square root of 36 is 6. And what we've done here is we've gotten rid of the radical on the denominator. This simplifies a little bit further. 2 over 6, the 2 and the 6 cancel out, and you're left with a 3 on the bottom. Square root of 3 over 3. A shortcut, a trick, is to say that when you have a square root divided by a square root, those numbers can cancel out. So square root of 2 over the square root of 6, 2 over 6 cancels square root of 1, square root of 3. Now we're just multiplying by the square root of 3 over the square root of 3, and we're left with square root of 3 over 3, which is a shorter, quicker way of getting there. Example 4, this is a fraction inside a radical, and what I'm going to do is to turn it into the example like example 3. We can take a fraction and take the square root of the top, square root of the bottom, so this becomes square root of 7 over the square root of 3. Multiplied by the denominator, square root of 3 over the square root of 3, we're left with square root of 21 over the square root of 9. Hopefully you'll see pretty quickly, when you multiply by a radical by itself, you get what was inside of it. Square root of 3 times the square root of 3 is 3. So we're left with square root of 21 over 3. See if you can give these 4 a shot. Pause the video, and I'll be right with you. Alright, these are the 4 answers. Hope you did well. Okay, we actually did some of this on the other side. Operations with radicals, we're going to talk about multiplication and then addition, subtraction here. We did division really on the other side. If you have multiplication, you multiply the numbers on the outside and you multiply the numbers on the inside, but you don't do outside with inside. So example 5 here, 3 square root of 6 times 7 square root of 3. What we can do is we can multiply the 3 times the 7, the numbers on the outside, 21, and then we can multiply the numbers on the inside, square root of 6 times the square root of 3 is the square root of 18. From there you simplify. Square root of 18 can be simplified further. There's a perfect square that's in it, or that's 2 times 3 times 3. 3 comes out, 2 stays in. 21 times 3 now is what we have on the outside. We're left with 63 square root of 2. The main thing with this is to multiply the numbers on the outside, and then multiply the numbers on the inside, then simplify your radical. Give 9 through 12 a shot on your own. Okay, hopefully that went well. Let's take a look at what happens with addition and subtraction now. Um, to do addition subtraction, you simplify the radicals, and then you combine like terms, like what you do with variables. And I'll try to explain that with this example over here, just to show me that you're paying attention or that you're listening here. If you'll put a star over here to the left of the addition subtraction, that would be great. So the way this works at example 6, 6 squared root of 5 plus 8 squared root of 2 minus square root of 8 plus 3 squared root of 20. We want to simplify those radicals first. Square root of 6, or 6 squared root of 5 will not simplify. 8 squared root of 2 will not simplify on its own. But the square root of 8 will. There's a 4 goes into 8, or there's 2 times 2 times 2 is what 8 is. We get 2 squared root of 2. The square root of 20 simplifies. That's 4 times 5. Or it's 2 times 2 times 5, but a 2 comes out. So 3 times 2 becomes 6. The 5 stays in the square root of 5. Now what we have here, this is like having 6x plus 8y minus 2y plus 6x with those terms there. We're going to combine the like terms. So the 6 squared root of 5, 6 squared root of 5 will go together. The 8 squared root of 2 and the 2 squared root of 2's go together. Now you add. That's like saying what's 6x plus 6x? Well, 6 squared root of 5 plus 6 squared root of 5 is 12 square root of 5. What is 8 square root of 2 minus 2 square root of 2? 6 square roots of 2. So the radicals behave like variables when you're adding and subtracting. Give these suckers down here a shot. All right, here are these answers. And I hope that went well too. Last piece of this. This is actually out of section 8.1 of our textbook about geometric means. Remember that the means of a proportion, if we have the proportion A over B equals C over D, which part is the mean? Or which part are the means, I should say? The B and the C. Now, if the means are equal, then they're considered geometric means of the proportion. This will make a lot more sense, I think, with this example. Example 7, find the geometric means between 3 and 6. Well, if we set a proportion of 3 and 6 being the extremes, and we set x and x as the geometric mean, where the means there are the same, now we're going to solve for x. Well, how are we going to do that? We're going to cross multiply. 3 times 6 is 18. X times x is x squared. Get the x by itself, take the square root of both sides, and we're left with x equals the square root of 18, like what we've just been having simplifying. How does this square root of 18 simplify? It's 3 square root of 2. So the geometric mean between 3 and 6 is 3 square root of 2. So that's what a geometric mean is, and I'll show you where that comes into play with the geometry once we get into class. But for right now, I'd like to see if you can come up with these 4 geometric means. Oh yeah, I was going to show you this shortcut. If we have 3 and 6 here, you may have figured this out as you went, but do you see that if you're finding the geometric mean between 3 and 6, really what you do is you multiply the 3 and the 6, 18, and you take the square root of it. So it's a pretty simple short thing to do once you realize what that shortcut is. Here are these answers, and we'll go over this, of course, next class. Let me know what questions you have, and hopefully you figured out some of the stuff as you went along. Have a good night's sleep. Good night.